introduction on gap and flushness. Here, these are the table of contents, and we have first the introduction on the course. Then um, we would introduce the current trends of this subject. Then we introduce the state of art in this field. Then I show you the leading software and hardware related to this field. Then we would have the technical content, job roles and prospects, opportunities in the industry. Then I would give you a brief introduction on the case study that we are going to speak about in the future during the course. And then I will tell you how to get into this domain. So let's have the introduction. What is the gap and flushness? Basically, gap and flushness measurement is commonly carried out to inspect fit and alignment between two surfaces. For example, the gap between car door and body panel, or body panels on airplane fuselage or wing sections, and even the fine clearance gap between an engine turbine blade and the casing in which it sits. So why do we need gap and flushness basically? Look at the picture. You see there are myriads of different components which would be assembled to create a complete vehicle or any other product. As you know, there are hundreds of components that go into a finished product, particularly in the automotive and aerospace industries. Each component may be manufactured by different suppliers, potentially in different locations, using many wide and varied processes that eventually all have to fit together to make one product. This means that fit and quality control is vital, and gap and flushness measurement is highly beneficial. If fit and finish is out of a specification, it not only affects the aesthetic or cosmetic appearance of the product, but also the performance and efficiency or risk of the failure. Not only these criteria is considered, but also sometimes we need gap and flushness because I would give you an example. For instance, consider the exterior of the car, where we have the gasoline door lid. Gasoline door lid should be understandably aligned with the exterior of the vehicle. But since it's going to be opened and closed thousands of times, so it needs to be considered in such way that if after, 2 years using that, we wouldn't be faced with a bulge on the exterior of the car. So we need a flushness, in the reverse direction into the center point of the car. The negative value of the flushness. So that if after, thousands of times, opening and closing, something happened, it couldn't be observed, and it couldn't make problem with the appearance of the car. So gap and flushnesses are really vital and essential to be considered during the vehicle design. So let's have let me tell you more about the aesthetic of or cosmetic quality of the car, which has no precise definition, since it is a qualitative product attribute that is perceived by a customer through visual inspection and comparison. Variation of features such as the size and shape of gaps and the flushness between mating components are areas that need to be tightly controlled during design and manufacture in order to maintain the aesthetic quality of a product. The ability to predict and assess how manufacturing variation will affect the aesthetic quality of a product early in the design process results in fewer design change due to unanticipated problems later in the product lifestyle. Look at this chart, which I would show it in different designations during the session many times. But first, look at this. See the blue-red portion on the top, which is representing the engineering phase of designing, in which the CAD and fixture design would be conducted using GD&T and tolerance analysis, simulation, and manufacturing processes would be conducted in this phase. After that, we would plan how we are going to measure by different methods to plan the inspection structure that we are going to go with. After that, we would reach to the quality control stage, in which we would inspect the quality of the vehicle by real-time monitoring, which are all included in quality monitoring, and is the step, the first step before we are going to enter the manufacturing phase. In that step, we do the quality monitoring, quality reporting, and part measurement. After that, when we are going through the manufacturing, we would need to do the problem solving by root cause analysis or other methods. Now, let's see what are the current trends in this field, which is an advanced engineering field. Look at this car and consider that as a major step of car body design, gap and flushness of the body exterior and interior trim would be defined within the styling demand. These values are gained by experience, knowledge, benchmark of trends, and by considering the manufacturing capability of companies. Well, it is obvious that when we are going to start a vehicle design, the first step is to draw in a style of the car. But it is not just about painting or just the pure drawing. In this step, the designer or the stylist do this design based on some knowledge. For instance, the stylist has observed many different vehicles with many different positions of components with different styles, and then they decide how to do the style of the car. And then after they did it and they decided what the gaps and flashnesses of the exterior of the car would be, then they inform the engineering team to help them achieving that goal. I mean that in this way, the engineering team is supposed to achieve the criteria employing different engineering methods and techniques such as GD&T and stack-up analysis alongside with the operation of various softwares. Now look at the car again. You see some points on the exterior of the car, which is marked by numbers. The first number represents the gap between hood and headlamp, which is considered to be, for example, 4 millimeter with a tolerance of 1 millimeter. Then the number 2 is the gap between bumper and headlamp, which is 2 millimeter plus minus 1 millimeter. I mean, tolerance is 1 millimeter plus minus. Number 3 is the gap between bumper and fender, which is considered to be 3 millimeters plus minus 1 millimeter, and the gap between hood and fender, which is 4 millimeter plus minus 1 millimeter. Consider, guys, these gaps are I mean that I say it again. I mean that I remark that these gaps and flashnesses are considered for different aspects. First is the beauty or the cosmetic quality of the vehicle. Then there are some criteria that these gaps and flashnesses are needed to achieve those criteria. Okay, now let's speak about a really important and crucial concept, which is named as stack-up analysis. During the conventional approach of gap and flushness analysis, we have a series of different mathematical manipulations named as stack-up analysis, in which the values of mating components, tolerances, will be computed by means of a general formula. Tolerances of stamping parts, jigs and fixtures, dimensions, hemming, and etc. will be taken into account. As the first step of the design, we would have analysis of master section. Okay, I'm asking the students to tell me if they know what is a master section.
Guys, you can use the chat box to give your answers.
Okay. Hey guys, does anyone know what is the master section?
So if you guys don't know, you can say no as well. It's perfectly fine.
Okay, I will tell you. You're here to learn. No problem. The master section is a really advanced step of vehicle design that I was not expecting these young people to know that. Then I mean that after the stylist of the car provides the complete style. I mean that all-round style with everything included. It gives it to a expert engineer. I'm receiving a error in which it says that my internet connection is unstable. Do you hear me clearly?
Yeah, we can hear you. There's a bit of lag, but that's fine. We are able to follow.
Okay, that's great. So in this step, that expert guy starts to put and arrange different components based on the style that the designer of the vehicle style gives it to them. Let me see. Okay. For instance, the border of the vehicle is defined by the stylist. The person which is going to define the master section puts the components of the back door in the border. I mean the end of the ending border of the car, and includes different things there. I mean, for instance, the door of the I mean the latch of the back door, and different hinges or fixings, and put them there, considering that these aspects will affect the gap and flushes in the future. I mean, that guy has the experience to know that in which way these components and these designation of those components will affect the gap and flushes in the future. After that, let me tell you again that in this stage we would define and decide gap and flushness according to master section from design. This is the backbone of the design, and the rest of the procedure would be founded upon this aspect. Okay, what happens next? Then we would have the concept of GD&T and stack-up analysis, which means that we review and analyze stack-up tolerances, and MCP means the master control points with engineering and design teams simultaneously. Okay, don't worry about those, that MCP concept. This is not required at the moment. I would teach it to you in the rest of the course. Here in this stage, we do the GD&T and stack up analysis of the product, and we would define the process and the design procedure. After that, we do the countermeasures. I mean that if we are faced with different problems and difficulties with regard to the gaps and flashnesses, we would think about the best countermeasure from issues or problems. After all, if everything is okay, we would start our progress to produce the vehicle by modifying the product, process, and design for the best condition. But if not, we should return to the GD&T and stack up analysis stage. If it's still, if it's understood, I would give you a more clear flow chart here. Here we would have this design procedure, which starts with the styling demand, in which the gap and flashnesses would be defined or would be illustrated. Then the concept design and section book would be prepared by that expert guy, which I don't know the name. And in this stage, those gap and flashnesses would be completely defined. Then we go for a GD&T tolerance analysis. And after that, we would create a tentative 3D CAD design. I mean, we would have an approximate schematic of the 3D CAD of the vehicle, by which we would be more, I mean, that we would be able to do the stack-up analysis better. A stack-up analysis would combine the different tolerances of the vehicle and do the summation on them, and then we could see that in which part we should make changes so that we can achieve the complete gap and flashness quality. After this stage, if we have achieved those desired gap and flashnesses, we would go through the rest of the design procedure, will be the comprehensive 3D CAD design. I mean, its name is detailed design. But if not, we should return to our design by checking the components which are the most potential ones causing the alteration, such as fixings, hinges, and reliefs. I mean that we may need to look at our holes in different components which might be a little bit tight, and we should give them more relief so that we can adjust the gap and flashnesses better. In this way, we return to the second stage, which is the concept design and section book about that guy. And then we would go through the procedure again. And after checking, I mean that after doing the stack-up analysis, again, we would ask that if we have achieved desired gap and flashnesses or not. If yes, okay, we go through the detailed design. But if not, we're obliged to ask the styling department to change the design completely, because we would explain them that we are not able to achieve these gaps and flashnesses that you have defined because of different criteria during our manufacturing. In that way, the styling department would change the styling demand, and we would have the complete procedure again. Okay, let's go for the state of art in the field. I mean, that's what I explained during the previous section about the current trends, was what normally happens in the industry of vehicle manufacturing. But at the very edge of the technology, we would have other options. I mean, because of so many demands in reputable companies like, for example, BMW or Mercedes-Benz or Airbus, Boeing, I mean that the designers would have a visual facility to have the appearance of the product better. The assessment of the aesthetic quality normally employs physical prototypes. I mean that in not such reputable companies, or in the past, companies were making prototypes so that they could observe what is going to happen. But these prototypes, I mean these physical prototypes, are very time consuming and expensive to produce. For this reason, there is an increasing demand for virtual prototype or digital mockups. In addition, some higher degree of physical realism that accurately simulates products variation resulting from assignment of tolerances and manufacturing variation is being developed. Tools that are capable of interactively modeling such real-world variation could enable engineers to undertake predictive design and study what-if scenarios. Now we would go for the concept of vital, or visualizing the impact of tolerance allocation.